All right, second part of today's lesson is lesson 99. And remember, we're talking about geometric progressions and arithmetic progressions. Remember, on the bottom of page 565, a sub n is equal to a1 plus n minus 1 times the difference. So this is arithmetic where you're adding. And then the geometric, it's a sub n is equal to a1 times r raised to the n minus 1 power. So this is arithmetic, and this is geometric. All right, so on page 566, the first problem says, find the 10th term, so we're looking for A10, in the geometric progression that begins x squared of 2x squared 2x cubed. So they give us A1. We know A1 is x. Looks kind of funny. They give us x is A1. They give us x2 and x3, but they don't tell us what r is. But if I multiply x times r to get this, or I multiply this times r to get this, can't I just divide any two consecutive terms and find out what r is? Yes. So we can either take the square root of 2x squared and divide it by x, or we could take 2x cubed and divide it by square root of 2x squared. It doesn't matter. This will give us what r is. So r is going to be the square root of 2x, isn't it? All right, so back here, A10 is going to be A1 times r raised to the 9th power. So A10, A1 is x, and then r is the square root of 2x, and that's going to be raised to the 9th power. Okay, so here we have x, and this will be the square root of 2 to the 9th power and x to the 9th power. So let's look at this off to the side. This would be 2 to the half if it's square root. So it'd be 2 to the 9 halves. So this will be 2 to the 9 halves. And then x to the 9 plus 1 would be x to the 10th. All right. Okay, the next one says find the 4th term. So we're looking for A4 in a geometric progression that begins 2 plus square root of 6, 6 plus 2 square root of 6, 12 plus 6 square root of 6, and so on and so on and so on. Important part is it's geometric. So we know that A4 will be A1 times r to the 3rd. And we also know that A1 is 2 plus square root of 6. What we need to find before we can go on is r. So it doesn't matter to me if you take this one and divide it by this one, or if you take this one and divide it by this one. It doesn't matter. I choose to use the simpler one, so I'm going to say 6 plus 2 square root of 6 divided by 2 plus the square root of 6, which looks like it's not anything that's going to help us, but remember, we can multiply by the conjugate and simplify this. So the conjugate would be 2 minus square root of 6. Remember, it's the denominator with the opposite sign in between the two terms. So we'll use FOIL and multiply this, which will give us 12 minus 6 square root of 6 plus 4 plus 4 square root of 6, and then minus 2 times 6, because square root of 6 times square root of 6 is 6. In the denominator, remember the outer and the inner terms cancel. That's why we do this. So we get the first would be 4 minus 6. Now remember, this is r. So r will be equal to 2 times 6 is 12. So 12 minus 12 will be 0. We just end up here with minus 6 squared root of 6 plus 4 squared root of 6. So that's minus 2 squared root of 6 over negative 2. So r is equal to the square root of 6. So then this will be a4 will be equal to 2 plus the square root of 6 times the square root of 6 to the third power. And this, the square root of 6 to the third power is 6 square root of 6, right? So now we can just multiply this out and we'll have a4. So that will be 12 square root of 6 plus, this is 6 times 6, which is 12 square root of 6 plus 36. All right, so in each case we have to find out what r is first. Now, moving on, bottom of page 566, we have a ball is dropped from a height of 81 inches. So it's coming down like this, 81. So my first fall is 81. On each bounce, the ball rebounds 2/5 of the distance it fell. So this one, this is the first bounce, right? But this will be the second fall. Okay, first fall, second fall. But if they're talking about bounces, this would actually be, this distance here would be the same as this. So the first bounce is the same as the second fall. And this will be 81 times 2/5. So then if we went over here to the next one, the second bounce is the same as the third fall. So this would be 81 times 2/5 times 2/5 again, or 2/5 to the second, right? Okay, so down here, let's see what it says. How far does the ball fall on its sixth fall? So we're looking for a6 in this case, which will be a1 r to the 5th. All right, so a6 will be, a1 is 81, and r in this case is 2/5 because that's what we multiply in each case, times 2/5 to the 5th power. And if you put that in your calculator, you'll get the sixth fall would be approximately 82,944. So it started in 81 inches, and on the 5th fall, it's only down at 0.82944 inches. That's not a very bouncy ball, is it? It only took 5 bounces, and it's almost not bouncing up at all. All right, so that's enough on geometric progressions. Let's look on page 567. This example says, find the arithmetic mean of x and y. So that means what we're doing is we're going to put one number in between x and y. Now you guys already know what arithmetic mean is. It's the same as average. So we know that the average of these two numbers should be x plus y divided by 2. We know that without using the formula, but let's just go through and show this. This is a1, this is a2, which is the same as a1 plus d, and this is a3, which is the same as a1 plus 2d. All right, so a1 is x, and so a1 is equal to x, and a3, actually, y is equal to a1 plus 2d. So I can say a1 is x, so over here I can say y is equal to x plus 2d. So then x is equal to y minus 2d. Oh, and actually, let's go back. I need to solve this for D because I know what A1 is. Let's solve it for D. So this would be 2D is equal to y minus x, making D equal to y minus x divided by 2. All right, so now we can find out what A2 is. So A2, using this formula right here, A2 is going to be A1 plus D, which is y minus x over 2. So we get a common denominator, which makes this 2x plus y minus x over 2, which simplifies to x plus y over 2, which is what we said it was going to be. So the arithmetic mean is x plus y over 2. All right? Okay, the next one is to find the geometric mean. The geometric mean is also called the mean proportional, which we have in right triangles. So this one says find the geometric mean between x and y. So it's the same concept, except it's just geometric this time. So A1 is equal to x, A3 is equal to y, and the formula for A3 is A1r squared. So we know that
Here's
A1,
what I found.
we know that A1 is x, so we put x r squared equals y, and we're trying to find r, remember? So r squared will be equal to y over x. Now, the problem occurs that when we take the square root of this, we get r is equal to plus or minus the square root of y over x. And we know that we can just leave it like that for right now, because what we're trying to find is A2. We're trying to find this. So A2 is A1 times R. All right, so R is X. And now R, I'm going to take one of these at a time. I'll take the positive square root of y over x, which gives me x squared of y over, oops, sorry. Said the right thing, just didn't write it. X squared of y over square root of x. So if we multiply by square root of x over square root of x, we get x times the square root of xy over x, so those cancel. So we get positive square root of xy. If we change this to a negative, what's going to happen? The only difference is it's going to be a negative answer, isn't it? So A2 is actually plus or minus the square root of xy. All right, so that's for the geometric mean. Okay, so on page 568, one last problem here. The positive geometric mean of two numbers is 8. Okay, so that means we have 8 in the middle and we've got two numbers. And it's a positive geometric mean. The difference between the numbers is 30. Find the numbers. All right, so one of these is going to be larger than the other one. Doesn't really matter. I mean, obviously, if we're going in this direction, this would be larger, this would be smaller. So it says the difference is 30. And the geometric mean is 8. Well, we just found the formula for the geometric mean in the last problem. It was the square root of xy, wasn't it? Okay, so that would be here, it would be the square root of ls is equal to 8. Now, we don't want that radical in there, so how do we get rid of it? Right, we square both sides. So ls is going to be equal to 64. So we have two equations. I can say from here that L is equal to 30 plus S, and then we can put that right here for L. So that will give us 30 plus S times S is equal to 64. or s squared plus 30s. And then if we bring the 64 across, we get minus 64 is equal to 0. So let's see how that might factor. If it doesn't factor, you'll just have to use quadratic formula, but, 32 times 2, right? So plus 32 and minus 2. So s would be equal to negative 32, or s would be equal to positive 2. And then we can take each one of these and plug them back into this equation, or we could put it there, it doesn't really matter. So I could say that L is equal to 30 plus a negative 32, so L would be equal to negative 2. Does that make sense? Is L bigger than S? Yes. And here we do the same thing. L is equal to 30 plus 2, so L is equal to 32. So there are actually two pairs of numbers that will work to give us that geometric mean with that difference. All right, thank you very much.